Now, let's move on to the Gaussian copula. At the very top of the left panel, we can see that the Gaussian copula is dependent on the parameter rho. This parameter represents the correlation that defines the relationship between the variables whose distribution is being modeled. Initially, this correlation is set to 0.1, which is quite low. Below that, still in the left panel, we have Kendall's tau, Spearman's rho, and two additional parameters measuring lower and upper tail dependencies, lower tail dependence and upper tail dependence, at the very bottom. The values of these four dependence measures, which are defined in the left panel, are also displayed in the horizontal bar at the top, above chart A and chart B. From right to left, we see the values of Kendall's tau, Spearman's rho, lower tail dependence, and upper tail dependence. These measures will be displayed in the same way for the other copulas later on. We also have visualizations. Chart A shows the PDF plot, meaning the probability density function of the Gaussian copula, represented in 3D. On the right side, Chart B presents the density of the Gaussian copula in a contour plot. This is a top-down view of the copula surface, making it easier to see the levels at which PDF values are located and in which regions of U1, U2 they occur. Now, if we set the parameter rho to a relatively low value, for example, minus 0.9, we can clearly see that the highest densities of this copula are concentrated in the corners where U1 is low, close to 0, and U2 is around 1. Here, we see an example of such density behavior. The PDF has a high value in this region compared to neighboring areas. A similar effect is visible in the opposite corner, where U1 is around 1 and U2 is close to 0. This can be seen quite clearly, but it may be even more evident in Chart B, which shows the contour plot. In Chart B, it is perhaps more noticeable that when U1 is close to 1 and U2 is close to 0, we have relatively high PDF values. This type of copula models negative correlation between the variables. In the contour plot, we can see how these contours are distributed. They align along the diagonal, stretching from the bottom right corner to the top left corner. Regarding lower tail dependence and upper tail dependence, the Gaussian copula does not model tail dependencies, so these values are equal to 0. Meanwhile, Kendall's tau and Spearman's rho are at low levels, somewhere close to -1. Setting the rho parameter to a relatively high value, close to 1, here at 0.9, we see the opposite situation. We can observe that the high-density regions appear in different corners, in different spaces than when rho was at -0.9. In the 3D plot, we can see that when U1 and U2 are close to 0, the PDF is relatively high. This is also visible in the right-hand plot, Chart B, where yellowish areas appear in this region of U1, U2. A similar pattern occurs in the area where both U1 and U2 are close to 1, where the PDF is also very high. This can be seen clearly on the right-hand plot. We can say that the bulge visible in Chart A in the 3D plot is represented in a contour form in Chart B. This bulge corresponds to locally increased PDF values, with densities concentrating along the diagonal running from the bottom left corner near the point 0, to the top right corner at point 1, 1.